Hello, Farabi. Farabi.
Hello, sir.
Hello.
Yes, Farabi.
Yes, sir.
Yes, can you read question number 24?
I am reading. Which diagram shows the formation of real image of an object or placed in front of a converging lens?
So you got it printed, this worksheet?
Not yet, sir.
Okay, please have it printed, huh? It will help you a lot if you get it printed. Farabi?
Okay, sir.
So here we have very important information in the question, that is real image, right? We will see there will be real image and O in front of the converting lens. So these two information is helping us to get the correct answer. So yesterday means the day before yesterday, last class, we said that these two, A and C, this cannot be answer, right?
Yes, sir.
Why? Because they are showing wrong, right?
Yes,
This
sir.
one is showing diverging and this one is showing reflection. So either B or D you have to choose. So B was chosen by Mahi and Monica previously, uh, and they most probably they were thinking that this one is the focal length, and from focal length, if the rays are going, then they are going parallel to other side.
Sir,
Maybe
sir.
yes,
Sir,
maybe
we chose Dhaka D.
you chose Dhaka, both of you.
Yes, sir.
Sure.
Yeah, means I chose Dhaka and I said Dhaka. He
Okay.
also chose Dhaka, I guess.
Yeah. Mahi also chose Dhaka.
Yes, sir.
Okay. And I told you to think again, right? After choosing
Yes, sir.
Dhaka. Then you are still in Dhaka or you went to Bangladesh?
Dhaka.
You are still in Dhaka. Yes. We all are in Dhaka, right?
Yes, sir.
So we all stay in Dhaka. Look here. Why it is Dhaka? Why we are choosing Dhaka? Because we are having here real image, right? And we are having
Yes,
here
sir.
in front of the converging lens, and you see the rays are converging here, right? And if it is real, that means the image will be inverted, right?
Yes,
If
sir.
if we have one screen here, like here, I'm showing you. Here, if we have any screen, then you will see the ray. This ray is going here up, and this ray here is going down, right? From lower part is going up, and from upper part is going down. So it's becoming inverted, right? Isn't it? Are you clear what I'm saying? Hello?
Yes, sir.
This ray from upper side is going down, right? And from its lower side is going up. So it's inverted. So in real image, it's inverted. Always in real image, the image will be inverted, vertically inverted. That's why the answer is Dhaka. Okay, done this one. Okay, 24 is done.
Yes, sir.
The answer is all right, your answer. Now we are having structured questions homework. I gave you structured questions homework, right? Two,
Yes, sir.
1 and 2. Did you try?
Yes, sir.
Okay, what about Farabi?
Yes, sir, I tried.
You tried. So, can you read it, Farabi? Farabi, can you read, please?
1.1 shows the light in air striking the vertical side of a rectangle glass block at an angle of incidence of 60 degrees. The refractive index of the glass is 1.6. The light travels in the glass and strikes side XY at P. Underline all the terms that describe a light wave.
So this one
Electromagnetic
actually, this idea is actually from topic 13. Okay. However, we will try to get it. It's simple thing. Farabi, you know it, right?
Yes, sir.
Light wave is uh,
Transverse waves.
yeah, transverse wave, and light wave is electromagnetic wave, right? Both. Light
Yes.
wave is electromagnetic wave, and light wave is also transverse wave. Is it clear? So you should
Yes,
underline
sir.
both. Farabi, are you writing on your copy about structured questions? One, and this is part one of one. Farabi,
Yes, sir. I'm writing.
yeah, write it. That one. The answer is electromagnetic underlined and transverse underlined. Then part two. Can you read Farabi?
Yes, sir. I'm reading. At the point where the light enters the glass, the angle of refraction is R. Calculate angle R.
So they are saying you to calculate to calculate which formula you will use. Which formula you will use, Farabi? Yeah, Monica.
M is
Monica,
equal to sine I by sine R.
yes, sine I by sine R. Very good. Your formula is correct. Then you will get it directly or you have to rearrange.
Mm, Rearrange.
Yeah. How will rearrange this?
Mm, R is equal to sine inverse by sine 60.
Right. Farabi, right. So the rearranged one, we have to make R as the subject, right? as we are going
Yes,
to
sir.
find out. So if you make R subject, then it will be sine inverse sine I by sine I by n, right? In bracket. So Farabi, did you understand it? How we rearranged it?
Sir.
So write it and get the value. Tell us the answer. Your sine I, you already got sine 60 degree, right?
Yes, sir.
Then n is also given. What is the value of n? N is refractive index, right?
Yes, sir.
So
Yes, sir.
what is the value? What
1.6.
is 1.6? Yes. So you write these values sine 60 by 1.6 and in bracket you give and then outside you write sine inverse. You'll get the answer. Okay, have you got the answer? Have you got the answer? Hello, Monica, Farabi. Hello, Farabi. Farabi. Hello, Farabi.
Time calculating.
You are still calculating. So long.
Time.
Yes, Mahi,
Sir, 0.54.
0.54. How have you did this? Sine inverse. Sine inverse in bracket you give sine 60 degree divided by 1.6. Yeah, Monica. Monica,
Yes,
what's your
sir.
answer? R.
33
Sir,
degree.
32.77.
How much?
Thir-
32.77.
Okay, 32.77. Yes,
33
this one.
degree.
Yeah, you got directly 33, Monica.
No, I just did the math. Like after point there is 7, so I take 1. So
Okay,
it's
then
33 degree.
32.77 means 32.8, right? Then it
Yes, sir.
you can write it as 33. So Monica got 33, right?
Yes, sir.
Uh, so it's very close, right?
Yes, sir.
Our answer is 33 degree. We can write, or if you are right, 32.8. That is also correct. No problem. Is it clear?
Yes, sir.
You can write both, but you should give your degree symbol. Huh? I cannot give degree symbol. I have to sketch it because in our computer the keyboard does not have any degree symbol. Okay, now
Sir,
Mahi, Walaikum Salam.
sir,
Question number 1 and question number 2 we gave homework, right?
yes, sir. Sir, I don't have my worksheet right now. I'm in someone else's room.
I'm not getting you. What you are saying?
Sir, I don't have my worksheet.
Okay, so you are traveling.
Yes, sir.
Where are you now?
I'm in someone's house.
Okay, someone's house. So you forgot to bring the worksheet.
Yes, sir.
So you can calculate it without your worksheet. You can calculate it. And I asked you that did you try question 1 and 2?
Yes, sir. I did try.
Then you can remember some of the things, right? If you tried.
Um, sir, I'll try.
Yeah. So we got here for question number 1, part 2. The angle R is 33 degree. Okay. Angle R means this angle, angle of refraction. Okay, when light rays travel from air to glass, that time the angle we got R, angle of refraction, we calculated using the formula n equals sine I by sine R, and we made R as the subject. It comes sine inverse sine I by n by rearranging. Then we put the values. Sine I means sine 60 degree, angle of incidence, and n given refractive index 1.6. Then we got this answer. Is it okay, Mahi? Hello, Mahi. Are you clear?
Yes, sir. It's clear.
Okay. So you take these notes. If you cannot remember or you couldn't solve this part at home, you should take this note quickly.
Okay, sir.
Okay. It is 1 structured questions, 1 part 2. Do it fast, huh?
Okay, sir.
Then you check part 3. Monica, can you read this part?
Sir, I can see the recording and do, right?
Yes, yes, you can see the recording. Recording is there. Okay, now we continue then, huh? Part 3, Monica.
Okay, sir.
Monica, can you read?
Calculate the critical angle C for light traveling in the block. I use the formula n is equal to 1 by sine C.
Yes. So you use the formula, then what critical angle you got?
39 degree.
39 degree you got. How you got that?
Mm, C is equal to sine inverse and then bracket 1 by 1.6.
So your answer is correct. Yeah. Your answer is correct. It is 39 degree. Now, Farabi and Mahi, did you try? Can you remember what's your answer, Mahi? When did you try? Did you use the same
Sir.
formula?
Yes, sir.
So you got the same answer, 39 degree. You can do it now even. You have the calculator, right? Someone's house.
Um,
You should
no, sir.
man
Like they just moved. That's why.
you should manage the calculator. Uh, what you are doing is not a big deal, huh? You can travel with calculator and
Yeah.
everything. Next time you remember it, huh? So
Okay, sir.
Farabi, what you got?
39.
39 you got. How you got 39? This way, right?
Sine
And
inverse by 1 by 1.6.
1 by sin c, right?
Yes, sir.
Then how can you rearrange sin c, right?
Yes, sir.
Sin c equals 1 by n, like before. Then c equals sin, even this one is easier, right, than previous
Yes,
one.
sir.
Sin inverse, then 1 by n. Put the values, then you can get the answer 39 degree. Okay,
Yes, sir.
very easy. 39 degree. I am writing so that they who can't do, they can see the recording and they can get the answer, right? Now, next part. Now, Monica, I think you are feeling confident, right? You are
Yes, sir.
getting the answers and you could solve them. It's really great that you got the correct answers. Very good. Then continue, Monica.
At P, the angle theta between the ray and the normal is given by theta is equal to 90 degree minus r. State and explain what happens to the light when it strikes side X and Y.
Side XY. We read
Yes,
it.
sir. I can understand.
You we read it XY. Okay. So we look at the diagram. We'll understand then. Look here. We have XY. This surface, right? And they are saying theta equals how much? Theta equals how much?
90 minus r.
Yes, we write it here. Theta equals 90 minus r. So r you got how much?
33.
90 minus
33.
33. Okay, then what is the value comes?
57.
57 degree. And this 57 is greater than critical angle, right?
Yes, sir.
Yes, sir.
So if it is greater than critical angle, then how can we uh, consider it? Will it be refracted or it will be reflected? If the angle of incidence, theta is angle of incidence, right?
Yes, sir.
Here, so if it is greater than critical angle, then what will happen? Light will be refracted or reflected.
Reflected.
Reflected. So this reflection is not normal
Reflected.
reflection. It is special reflection. It has a particular name. What type of reflection it is?
Total internal reflection.
Yes, very good, very good. This is total internal reflection. So we will write it here, right? State and explain what happens to the light when it strikes side XY. So what you will write here? As the angle of incidence is greater than critical angle, then light is totally internally reflected, right? Is it
Yes,
Sir,
clear?
I didn't understand.
You did not understand? You
Yes,
can
sir.
remember one thing that we had idea, uh, that is, if angle of incidence is greater than critical angle, then light will no more reflected. It will refracted. It will go for reflection. Can you remember that?
yes,
Yes,
sir.
Yes, sir.
I'm showing you here. You take the notes here now. Look, if here is glass, huh? Glass is denser, huh? Glass is denser medium and air is rarer medium. Okay. So here is normal. Now, if angle of incidence, you see here, angle of incidence is greater than critical angle. Here I is angle of incidence. It is greater than critical angle. We
Critical
know
angle.
we know if the angle is critical angle, then light rays will go 90-degree, right? In last class also we got that.
Yes, sir.
Can you remember? Light will go here if it is critical angle. But if it is more than critical angle, then light rays will not go here in the other medium. It will not refraction. It will go for reflection. What we get in optical fibers. Can you remember we did in optical fibers? Total internal reflection.
Yes, sir.
So light is going from denser to rarer medium and the angle is greater than critical angle. That time light is no more going to the refraction. It's returning back. Okay, this process is called total internal reflection. Is it clear now?
Oh, okay. Yes, sir.
So in our recordings of previous classes, I don't know or I can't remember that you left in that class while we discussed total internal reflection or not. So you please go through all the recordings, in Google Classroom. Okay.
Okay, sir.
So if you check out the recording, then you'll see that in the recording also we mentioned what topics which day we discussed, isn't it? So at
Yes,
least
sir.
from there you can identify where we discuss the total internal reflection. You check out that one. There you go. And take the notes on your copy. Is it clear? So what we will
Yes,
write
sir.
here? What we will write here, Monica? As angle of Monica, did you write anything here?
Yes, sir.
What you wrote? You tell me your one. Then I can understand your one is okay or I have to add something. Say.
I wrote that the light waves slow down when they go through the denser medium, and so the ray bends towards the normal.
Okay, only this one you wrote. But here you
Yes.
understood that it is total internal reflection.
Yes, sir.
So it's not like that it's normal refraction, what you said. But here we are having X, Y, right? I'm showing you again. Look here. They are saying what will happen here, right? If light rays come to X, Y, then what will happen? They are asking that one, isn't it?
Yes, sir.
So now we understand the angle of incidence here, how much? Theta. Theta is becoming
57.
57 degree, and our critical angle here was how much? 39 degree, right?
33. Yes,
39
sir.
degrees. So our angle of incidence is very big than uh, the critical angle, so it will be reflected, right? The
Yes,
light rays
sir.
will be reflected. So what we should write as,
Angle of incidence
yes,
is greater than critical angle.
yes, I'm writing also it as angle of incidence is greater than critical angle as angle of incidence is greater than critical angle, light will LIG is light will go for total internal reflection, okay? Or light will show total internal reflection. Is it clear now? Hello?
Yes, sir.
Yeah, Farabi, is it clear
Yes,
to
sir.
you?
Yes, sir.
Okay, very good. Then we are having the last part here. On figure 1.2, draw the path of the light after it strikes side XY at P and path of the light when it is again traveling in the air. Okay, so what we have to do, we have to go there. Please use your ruler. Huh? You draw this diagram. If you have the worksheet, that is fine. If you don't have, you again draw it on your copy. At least you should have the idea how it's going. We already got theta is 57 degrees, isn't it? Huh? Hello.
Yes, sir.
So you write here 57 degree. If it is 57 degree, then the other side also will be 57, isn't it?
Yes,
Yes,
sir.
sir.
Yeah, that means it is reflected, total internal reflection. So this side is also 57 degree and it will go till here. So this angle, it is also 57 degree. You write it. The way I am labeling, you should label this way. Otherwise, you'll forget tomorrow. Mahi, tomorrow you say how it is, sir. Okay, now you draw here normal. Okay, now you understand one thing that if it is 57 degree, then what is the angle of it? Can you say what is the angle this one? If it is 57 degree, then what will be the value of this angle?
Wait, sir.
Calculate 90 minus 50,
33.
33. So you write here 33. If it is 33, that means this one will be also 33, isn't it? According to
Yes,
geometry,
sir.
alternate angles. So we are writing here also 33 degree. Here I'm writing. There is no space, that's why I'm writing here. You can write on your copy. So this is 33 degrees. So if it is 33 degree, that means it's smaller than critical angle, right?
Yes, sir.
So if it is smaller than critical angle, then it will be refracted right in the air. And it will be refracted how? Angle of incidence, if it is here 33 degree, angle of refraction will be bigger, right? Isn't it? This way.
Yes, sir.
This way it will go. So you draw this way. Is it clear now? Just you have to show that this angle is bigger than 33 degrees. We know angle of refraction will be greater in air because it's moving away from the normal, right? Or it's bending away from the normal, isn't it? So you join after 10 minutes. We have last minute going. I think you all understood and you can draw. Okay.
Okay, sir.
Yes, sir.
Yeah.